Okay everyone, welcome back to the MONBUKAGAKUSHO video solution. And in this paper of 2016, we're gonna continue number 4 of Mathematics B part 1. So in this question of number 4, this looks like something a logic question or word question, right? So we're gonna dive into it. On the basis of the premises and the conclusions 1 to 3, the next page below, fill in the left-hand blanks with 1 if the corresponding conclusion is logically derived from the premises, and with 0 if it is not. And the premises is there are several 3-digit numbers NML, each digit of which is either 1 or 2. So I want to explain that NML is such a 3-digit number. So for example of NML, because the digit is either 1 or 2, so it could be 112, 121, 211, or 221 and others. And they said another premises here, there are some numbers with n equals 1 and other numbers with n equals 2. So the meaning is n could be 1 and could be 2, and some numbers there is, for example, 132 exists and 232 exists if this particular requirements here. And if m is 2, then n is 2. So for example, if we have m here is truly 2, then n must be 2, for example 223. And if L is 1, then n is 2. So if it is L is 1, let's say 1, so this is 2. For example, 221 is possible for this NML. So that's the premises. So let's see about the conclusion in the next page. And they say that the first conclusion, if n is 1, then m is 1. Number 2, there are no numbers with m equals 1 and n equals 2. And conclusion number 3, there are no numbers with m equals 1 and l equals 1. So let's write everything in the paper of our question here, number 4. The first is, for example, number 4 here. So there are several 3-digit numbers n, m, l, each digit which either 1 or 2. There are some numbers n is 1 or n is 2, and if m is 2, then n is 2. Then if l is 1, then n is 2. And let's directly see what the question about, the conclusion. What is our verdict for the conclusion? You see, if n is 1, then m is 1. If you see, in this particular conclusion, if n is 1, then m is 1. Is it correct or is it wrong from the premises that we have? They say that some numbers is n, the n is 1 or n is 2. So they ask n is 1. Particularly, there are no requirements here saying whether n is 1 is compulsory to have another digit of m and l. So if n is 1 and m is 1 is correct, because some numbers n is 1 exists, but maybe we don't know whether n is 1 then m could be 1, but we could say this correct. So we put 1, which means that the conclusion logically derived from the premises, meaning that this conclusion is correct. And for number 2, conclusion number 2, there are no numbers with m is 1 and n is 2. So they say the number with m is 1, so n must be 2. You see that m is 1, there's nothing m is 1 here, so we're going to look at n, then n is 2. But n is to exist, so there are no numbers with m equals 1 and n equals 2 is incorrect. because n is actually exist, and we don't know actually if m is 1 then exists together with n is 2, so we can say this is incorrect because there are numbers with n equals 2. And conclusion number 3, there are no numbers with m equals 1 and l equals 1. So we look again, we didn't see any m is 1, but with l is 1, it exists. So this is also incorrect, meaning that there are numbers with m is 1 and l is 1. So the answer to this number 4 for the conclusion of these premises and this conclusion is 100, meaning that conclusion number 1 is correct and conclusion number 2 and number 3 is incorrect. And in the next video we're gonna discuss of number 5 for MONBUKAGAKUSHO. Thank you for watching.